Okay, good morning, everyone. Good to be back again, India. 2 months back, I was in Wi-Fi KS. So now this event as well. So now today we are talking about bit of a spectrum. So now here's a question for you. Now, sometime when you do a spectrum analysis, this is some live capture I took once I customer end. So now you can see here there are some activity, channel 64 and channel 161. Now, do you know whether it's a Wi-Fi or this is non-Wi-Fi? So that's an important differentiation you need to make if you really want to understand what makes your Wi-Fi down, what's the problem. In that way, spectrum provide that detail. Okay. In that way, now we are going to learn about that in this particular presentation. So now, to understand whether it's a Wi-Fi or not, you have to know the fingerprint of Wi-Fi. In that way, OFDM here. Let me just. You can see here, sometime we have a 20 megahertz channel, we're dividing that to subcarriers. So now data will be not go all the subcarriers. So we have a null in the middle. So sometime when you look at the spectrum, if you see some signature energy like that, that's a clear indication of OFDM, okay? 20 megahertz kind of communication. But sometime if you're using legacy technologies like a DSS in the 2.4 band, you will see like a half circle kind of shape. In that way, that's an indication of you have a legacy Wi-Fi, especially 2.4 spectrum, you will see this. So if you know these two things, so sometime when you look at a spectrum, you can tell whether this is a Wi-Fi or something else. Now, the tool I use for this presentation is what we call Ekahau Sidekick. So now the advantage of this tool is it's a tri-band. You can monitor all the three bands, 2.45 gigahertz and 6 gigahertz. But this has a Wi-Fi adapters inbuilt as well. In that way, it goes the MAC layer detail and it can overlay that MAC layer information into the spectrum. That's what unique advantage you got with this particular tool. Now, if I basically show you with that information here, we can see that show Wi-Fi AP. In that way, not only they show the energy, now they will basically overlay whether is there any beaconing happening on that particular channel. In that way, you know certain information here, these are access point. But if you look at the right-hand side, there's an energy there, but there are no overlay of Wi-Fi. In that way, that is, we know this is something non-Wi-Fi. Okay, very, very important. So now, whether it is what kind of non-Wi-Fi, you will learn as the presentation go through. That way, if you have a spectrum analyzer, have a Wi-Fi information overlay, that will be the starting point, very good position to be. Otherwise, you don't know where the energy coming from. It's always a challenge to hunting them down. Now, when you go through this kind of spectrum analysis, so always you have one view called real-time view. So in the real-time view, you will have a, like now in here, you can see, it shows the current activity right now, live view in this moment. Now, in the you can see the legend here. It says spectrum utilization. In that way, this color indicating what the spectrum utilization is. Now you can see, now you know the OFDM pattern. Now you can see this OFDM. Here's OFDM as well. Maybe that side 40 megahertz, this time 20 megahertz channel. Now in the right-hand side, you can see color is green. So color green means low utilization. Maybe 5 to 10%, you can look at that. And then on the other side, if you have a orange kind of color, typically 40-50% utilization. But if you see dark red in the live view, that means 100% utilization, 90% utilization. That's something you need to worry about. Like sometimes this view providing a snapshot, momentary snapshot, but sometime when you analyzing Wi-Fi, that momentarily snapshot may be not good enough. Okay, you don't know what happened slightly before that. In that way, this view is important to understand right now. But now if I show you this kind of view, you may think now everything is really dark red. If you can read this value here, you will see utilization here is very high. Okay, but it's a good or bad. Do you know? Now, to determine that, you need a bit more historic data. Okay, that way, whenever you do the spectrum analysis, you need not only the real-time view, what does the histogram look like? Some people call it waterfall view. In that way, this kind of tool provide waterfall view. Now, if you look at the second view, you will see channel was busy only short period of time. Before that, it was like only primarily one channel being busy. This is typically Wi-Fi. Okay, when you're doing a data transmission, data frame will use the bonded channel. Management control normally use the primary channel. In that way, if you see only 20 megahertz busy, rest of the is not busy, that's a typical Wi-Fi kind of use case. Now, what is the color sort of signifying in each kind of view? Now, the first one, we said color signifying the spectrum utilization. But in the waterfall view, the y-axis is time here. Okay, so it's a O period of time, like a last 5 minutes, last 2 minutes. In that way, color signifying here the amplitude. In that way, these two visualization, color mean two different things. That's to be very clear. In that way, now the second graph, color indicating, like how loud the signal is. So now if it is getting a dark red, that means you are getting like a neg 30 dBm. That means you are very close to that energy source. If you are getting like a neg 92, neg 100, maybe far away. Now in this particular example, there are two access points you can see. AP number 1, we are getting like a neg 40 dBm kind of value. So you can see color is being here red. That means I am close to that access point. Now on the access point number 2, you can see I am getting a low amplitude there in the real-time view. This view I am getting like a yellow kind of color. That means I am getting like a neg 65 dBm. That means I am a bit further away from that AP. So now we discuss why certain 20 megahertz busy. That's a primary channel. Okay, in that way, this is a typically Wi-Fi normal use case. You will see this kind of spectrum. Now this is like a typical Wi-Fi in operation. If I'm doing upload, download like a speed test, you will see spectrum get utilized over a period of time while I'm doing upload, download. And then once that finish, it go back to normal. The beaconing kind of channel getting busy, other channel will be free. So now, sometime you don't want to misunderstand spectrum shows the energy. Where the energy is, it does not correlate to the throughput. Okay, in that way now one example is, I did this particular test, one of the hotel I stayed, very poor RF condition I'm getting. My performance is like a 6 Mbps, but still that does not really can measured by the spectrum. So there are two different things. Airtime, retries, those determine your data frame transmit opportunities. So your data rate depend on certain other factors. Now, what's a busy Wi-Fi look like? Sometimes you need to know. Now, this is like an interop last sort of maybe 2 to 3 weeks back. Now, when there are a lot of booths, right? Everyone putting their own SSIDs. In that way, conference menu like this always have a congested Wi-Fi. Now, if you look at Wi-Fi, every 5 gigahertz channel, you can see all red, orange kind of, sometimes they put 80 megahertz, 40 megahertz kind of channel, lot of SSID. Other than the Uni 3 band, everything is 40-50% busy consistently. Okay, this is like a busy Wi-Fi. You will see some spectrum like that, but there are no interference here. You basically creating a lot of Wi-Fi network that create the contention. Now, what about 2.4 in this kind of environment? Now, this is a 2.4 spectrum in that environment. Now, the important part to pay attention, channel utilization. Spectrum utilization here, almost like 100%. Okay, in the 2.4, almost unusable. You can still connect, but when you try to do some call or anything like that, video call or anything like that, nothing is working. In that way, now this is like if you're creating that much of contention, it is unusable. 3 channels to work with, you're creating a lot of SSID, a lot of access point on the same channel, creating very poor user experience. Now, you can see by looking at the real-time view, dark red, that means 100% busy. Okay. Now 6 gigahertz in that kind of environment, quite clean. That's because 6 gigahertz adoption is still early stage. Not many clients go to that band. If you want to have a good experience, go early to 6 gigahertz. That will give the breathing space for your client to get the best experience. Now, in that way, busy spectrum does not really mean interference. That's the thing to be come out. Okay? Sometimes busy environment can have a congested RF, But now we are going to look at what are the non-Wi-Fi thing it can have. Now they have many different phases. Now again, this is basically I'm getting from the Ekaho kind of class slide deck. So we teach them, students, there are a lot of interfering devices. You have to find this out in the different customer environment. So that way now I'll break into different band. Sometime these things can be other bands as well, depend on what you get. Now, one common interferer we normally see is nowadays these kind of motion sensor lights, typically common in warehouses. If you go, when you walk, light turn on automatically, those emitting energy into the Uni 3 band. You know, like this expanded view of that, you can see each light emitting energy, some narrow band. But if you look at the color of that, dark red, that means those are 100%, 90% making channel busy. So if you look at the waterfall view, those lines are very straight, right? Persistent. In the Wi-Fi side, you can see data and no data. It's like that. In that way, you know definitely this is a very common type of interference you will see nowadays. Not only warehouses, even you go to school, basketball court, these kind of lights are there. They don't know even. Now, what's the impact? Your AP try to avoid those channels. If an entire Unit 3 gone, you have a 4-channel left, 4-channel less to work with. In that way, your AP may not come there. But so now this is a second type of thing, what we call drone camera. So typically, again, you look at the color. Color is like a dark red. That means these are persistently emitting energy. So now, if that is the case, sometime now Ekaho, if you look at the waterfall view, it identifies as a continuous transmitter. So sometime these kind of spectrum tool fingerprinting the non-Wi-Fi interference as well. It can tell whether it's a camera or whether it's a microwave oven like that. In this example, it did not really classify as a video camera, but video camera has a signature like that. This is expanded view of this. So sometime if you're seeing a side lobe like that, that means video camera with the audio capability. That's basically indicating those side lobes. Now, sometime in 5 GHz, you need to be aware of this radar. So sometime DFS event, Wi-Fi can operate in this kind of DFS frequency. You need to, and you need to extend it. So now in here, you can see, this terminal Doppler weather radar. Now, left-hand side is like a 200 meters away from the radar. So you can see we are getting like a tiny pulse. Color is green. That means it not make channel congested. Even tiny pulse, but access point supposed to go away. Okay. Now the right-hand side diagram is 70 kilometers from that terminal Doppler weather radar. So it is detecting that far. In that way, access point supposed to, even tiny pulse should go away. Okay. So now again, this is another instructor from the Germany capture this. So in live, you very difficult to capture this kind of radar event. Okay, unless you go and hunting them close to this kind of places. Now 2.4 we use basically mostly nowadays everyone have a BLE enabled some wearable device. Okay, so now Wi-Fi access point typically AP beaconing. In the BLE world, your peripheral device advertise their existence. In that way, if you look at BLE kind of environment, you will always see this advertisement channel. So now they basically position outside 1, 6, and 11. In that way, they will not directly interfere with Wi-Fi. Advertisement communication, they position outside of 1, 6, 11. But when you starting streaming, you can see 2 megahertz kind of communication go across the band. But if you look at the colors, color is green. That means only 0 to 5% utilization. That will not make entire Wi-Fi down. Okay, they can be coexist, but your Wi-Fi performance will be go down. But if you look at the spectrum here, you can see the patches to 2 megahertz, 2 megahertz. Now in here, that's mean it is going to frequency hopping kind of thing. Now prior to Bluetooth, we had BLE, we had Bluetooth, which is using 1 megahertz, no advertisement communication. So that basically go across the band. Now sometimes when can Bluetooth become an interferer? Now if I show you one here, you can see the color is not green anymore. Like here you can see color is orange, red. So that means strong BLE activity, Bluetooth activity. So now in here, what's the environment look like? This is like a AR, VR kind of thing, like a cinema, VR headset, they use some Bluetooth for the controlling point of view. If you're doing this much of BLE, that can have a significant impact to your 2.4 Wi-Fi. Now, this is a microwave oven. So typically, microwave oven affecting channel number 7 to 11 kind of channel, 40-50%, depending on the leakage of the microwave oven. In that way, now you can see here, they're detecting the signature, it says microwave oven, because they know the signature of the disinterferer. But if this kind of thing happens, you cannot throw away microwave. You have to disable your 2.4, use 5 gigahertz, work around that, because we cannot get rid of the interferer. Now, this is another sort of motion detectors, like sometime 2.4 band, parking gates, they have those kind of thing. You can see very dark red, that means very strong interference. Now, so this is what sometime you will not see very common this one. Why? Because if you look at the spectrum here, entire thing is gone. Very dark red, that means entire spectrum is wiped out. That means somebody maliciously blasting energy. So now if you see something like that, you know somebody is doing malicious activity. You need to go and find it out who's doing that. But these kind of devices are very common. Now if you look at the utilization here, you can see 100%, 100%. That means even that spectrum I showed you earlier, Tokyo interop, if channel is 100%, naturally creating this kind of denial of service. Okay, so sometimes you intentionally create an environment like that, or sometimes you unintentionally creating more 2.4, you are creating like this kind of environment. Now let's look at the 6 gigahertz. Sometimes we told 6 gigahertz is very clean, no interferers. You should go for it, but you know every time somebody will use something. So now this is like a video transmitter. Sometimes you look at big event, people go around and recording. So they have some devices to communicate with their central control. They have some central video server within the venue. So they use some 6 gigahertz communication. In that way, in this venue, look like there are no 6 gigahertz Wi-Fi. In that way, their work not impacting Wi-Fi. But before you deploy this kind of thing, be aware impact to your Wi-Fi. Now, those 3 band, be aware of now what are the tools available for you to monitor the spectrum. So now, analysis point of view, if you really need some commercial grade, there's a one vendor called Aronia. They have a German-based product. You can monitor 2.4, 5 gigahertz, 6 gigahertz simultaneously. In that way, but these tools are very specific to layer 1. They don't do anything else. You have that layer 1 visibility best, but it's a commercial grade, expensive tool. Now, sometime Ekaho, the tool I mentioned, like this is the one normally I use. Sometimes not only a spectrum tool, it gives the capability of validation, wireless site survey. So spectrum being an additional component to it. So in that way, I use this tool because it has an integrated Wi-Fi overlay capability. Now, if you have some handheld tool like Netalai, you can use that, but you have to plug the external adapters, the spectrum adapters to work with. And then some other vendor called OCM, they have a spectrum adapters available. Some other software can be used. OCM also have their own Metageek product, but otherwise some other vendors supporting OCM adapters in their product. In that way, so now I have done some videos about this Wi-Fi. I have a playlist called Wi-Fi Killers. So if you want to learn, probably you can go and listen to those particular interference-related short videos I have done in the past. With that, I can finish the presentation.
Thank you, Rasika. Again, Rasika has come all the way, second trip this year, so we should give more airtime to get this advantage. So questions, please put up your hand and mic will come. There are 2 hands, so please get the mics to the hands, please. There's another hand here. You can get the mic to this person. While you ask, please go ahead.
Hello. Hello. Hello, Rasika. One question is, do the Wi-Fi driver or in any enterprise or any Wi-Fi driver provide this interference in noise output? Actually, normally we will take minus 95 dB as a noise. in a general theoretical way, but actually whether driver will provide in a realistic way in real environment.
I'm not 100% sure, but now once some vendors access point, probably you can get a spectrum kind of mode, right? In that way, some vendors allowing, if they have additional radio, they can use that radio to spectrum XT kind of mode. In that way, as long as a short period of time, you can use that radio to monitor. But the question about that, I don't know the exact detail about that.
Then we cannot rely on SNR, right?
No, this is like a layer one. Probably, like you have to basically get the energy measured in the layer one level. Like we are not go to the MAC layer, RSSI, or we don't really go to that level.
Jia, while you answer, can you also comment as an AP vendor, do you provide spectrum analysis for your customers?
No, yeah, we don't. Yeah, my question is regarding the non-Wi-Fi interference classification that ICAO is doing, right? So is it purely based on image processing of the?
Yeah, purely based on the RF signature. Like that way, typically microwave oven, typically we know if this particular channel getting busy certain level, they look at that fingerprinting of that. They don't really go deep. Ideally, each different microwave should have a unique signatures, right? In that way, I don't think they will go to that level. Like a broadly, they're classifying based on a generic kind of signature pattern.
So mostly image processing.
Yeah.
AI-based
Yeah,
image processing.
yeah.
Sitaram, can you just... while I asked by Sitaram, Sudarshan, what about Netgear? Like any spectrum analysis you provide to customers? No. But the chip provides spectrum analysis capability. Like, why are you guys not exposing it? Are you using it internally? Okay.
So there are a few people watching this online. So there's a question online from Sheila. What are the current interference mitigation mechanisms that exist in Wi-Fi 6 or Wi-Fi 7?
Typically, access point can avoid the channel, right? In that way, when you're configuring some RRM algorithm, you can program, if it's an interference, just avoid that. In that way, AP is supposed to go to a different channel. So like that, we are avoiding that kind of non-Wi-Fi interferences. Most vendors do that kind of automatic. As long as you leave the channel to automatic, they can go. If you statically assign, that will creating a problem if an interference comes to that channel.
Last one more question, given Rasika's travel distance, the air time should be proportional. Anybody wants to? Sudarshan, can you get a mic, please, to Sudarshan?
See, where do you see AI's role in enhancing the impact of some of these?
Yeah, I think definitely AI can help, in that way, as long as you can get the, as long as you have a spectrum adapter in your access point, as long as it's detecting these signatures, and then, for example, like a false positive DFS, something like that. Sometime access point, maybe Wi-Fi chip may be detecting a DFS event. Genuinely, it may not be DFS event. In that way, like that, if you have some capability and processing power, whatever the signatures you are getting, you can compare layer 1 signature versus what the layer 2 detected, and then can override. Like as long as layer 2 can get override beaten by layer 1 information. So like that, if you have a capability, I think that's where I think AI can definitely help in this space, right? Clearly identifying what's the interference is.
Yeah, last, Ashok, can you just pass the mic to Ashok? Yeah.
Thanks, Rasika. That's a very useful presentation. Am I audible?
Yeah.
So I saw that at the start of your slides, right, that you had represented it in a sort of a exhibition where you are trying to get these experiences rolled out. So there is Wi-Fi interference, there is non-Wi-Fi interference, and also the propagation environment, right? Because different malls or different outdoor units have different metals and so, meaning, does that also not contribute significantly to bad Wi-Fi performance? Because one is the airwaves and all that.
Yeah.
Should that also not be taken into consideration?
Yes, sometime, like material you have in the environment, reflection it create, that also contributing for your overall experience. Okay, that way, now energy level point of view, sometime this can be bouncing back signal, in that way that can create. So overall spectrum utilization, So signal may be impacted by that as well.
That could be a third comp.
Yeah, yeah.
Wi-Fi interference, non-Wi-Fi interference.
And the environment factors that can creating certain RF conditions. Okay, thank you.
Thanks, Rasika. Yeah, thank you.